Hi, good morning, guys. Today we're going to go over Chapter 2, Section 6, special functions. So we're going over piecewise defined functions. So the functions related income and tax is not linear function because each interval or piece of the function is defined by a different expression. A function that is written using two or more expressions is called a piecewise defined function. On the graph of a piecewise defined function, a dot indicates what the point is included in the graph. A circle indicates what the point is not included. So that means, as you guys know, closed circle included. This is stuff that you have seen. An open circle. And then the open circle means not included. Just as a study tip, the graph of piecewise defined functions, the graph of different parts of the piecewise function, may or may not be connected. A graph may also stop at the given x value and then begin at a different y value in the same value of x. So a piecewise function can easily look, let's say this is a graph, you can have a piecewise function doing a parabola and it stops right here with a closed circle, and then it'll have an open circle and then just drop. So a piecewise function is like two different graphs inside of the same coordinate plane. They may look different, they may look similar, they may sometimes connect, they may not sometimes connect. In this case, I drew one that is not connected, but they are within each other in the same graph. Now I'm going to go over how the different piecewise functions look and how you would graph them and or know how to solve them. So here we have a piecewise defined function, or a piecewise function for shorter. And they're going to tell us that the graph x minus 2, if the x is less than -1, and they're telling us that the graph is x plus 3, if x is greater than or equal to -1. So we have to identify that domain. Now, guys, this graph is based on the domain. So if we were to draw it, I'm just going to estimate it. If we draw the first one, I am going to draw it in blue. And I'm going to draw the second one in red. So if I draw the first one, I'm just going to draw. Okay. If I draw the first one, it has a point at -2. And it has a slope of 1. Okay. So we know the graph is going to look like this. They're telling us that the graph is existing when the x is less than -1. So right here, we're going to do an open circle. And because it's less, we have to go to the left of it. So the graph is going to look like that for the red one. Sorry, I flipped the colors. The red one is the top one and the blue one is the bottom one. Now, if I were to draw the second one, I'm going to start at +3. And then it has a slope of 1, right? So it keeps doing the same thing as the other one. Now, we're told that it has a slope of that, so I just kind of drew a few points. Now, it's telling us that piecewise of that function, it's only true when x is greater than or equal to -1. So we're going to grab that -1 and we can draw a line to it. Now, notice how the -1 right here is the point of separation between those two graphs. Now, that is where one picks up and one drops off. So if I wanted to do the domain for the red one, it's going to be from -infinity to -1 in parentheses. And if I want to do the domain from the blue one, it's going to be a bracket from -1 to infinity. Another way you can write this is x is going to be less than -1 for the domain. And you can also write the domain for the blue as x is greater than or equal to -1, which is what's written right here. Now, because that is what is written, you're not really specifying what the domain is, other than when x is greater or when x is less than. Remember, parentheses is like an open circle. It means it's not included. And bracket means that it's included. Now, here they want us to graph this piecewise function and to identify the domain and the range. So I'm going to go ahead and draw just a graph. Now, let's say I'm going to do the red one as the top one. It's telling us it has a y-intercept at 2. So I'm going to write a dot at 2, and then it says it has a slope of 1, so I can write over run 2. Yeah. So I can go up 1, run 1, up 1, rise 1, up 1, rise 1. And I can follow that same pattern to the left. Alright, so far this makes sense, right? Now before I draw this, I want to see, well, where is the cutoff area? The cutoff area is 0. So we're going to figure out, well, for the red graph, it's saying that that is true when x is less than 0. So because it has no equal sign, I'm going to make this an open circle. And then I can draw the stuff that are smaller than 0, so to the left of that graph. Making anything we have on the right not real for this problem. Now I'm going to do the other one in green. The other one starts at 0, and then it has a rise over run of 1. It's going to look like this, and it's going to look the same way the other way. Now this is telling us that x is true, the graph y is equal to x is true when the x is greater than or equal to 0. So it's going to be a closed circle, and then we're going to draw everything to the right because that is when the x becomes bigger. Now for the domain of the red one, we're going to use this type of notation. So it's going to go from negative infinity, because it's coming from the left to the right, all the way to 0. But because 0 is not included because it's an open circle, we're going to use a parentheses. And then the domain for the green one, it's going to be, well, it starts at 0 because that's the x value, and it's a closed circle, so it's going to be a bracket. And then we're going to go all the way to the right, and you see how there's an arrow, it keeps going on forever, so it's going to be 0, comma, infinity. I'm going to start setting up the graph for this equation. Okay, so this graph is going to be a little different because we're going to have 3 parts to the piecewise function, not just 2. So I'm going to do the first one in red. So say I'm going to start at positive 3, and then I have a slope of 2. Right? So I'm just going to draw kind of what it's going to look like. Awesome. Now it's telling us that this graph is true when x is less than 1. So right here at 1, I'm going to do an open circle, and then I'm going to draw less than 1, so to the left. Now this second one, I'm going to go ahead and do in blue. So we're going to start at positive 2, and then we have a slope of negative 1. So I'm just drawing a few points, and it's telling us that this equation is true from 1 to positive 2. So I can draw a closed circle there, and I can draw a closed circle right there. So this is only true for these 2 points, right? And then lastly, I'm going to do this one in green. We have y is equal to 3. So when y is equal to 3, it's just, remember, it's just a horizontal line all throughout both sides of the equation. So, but it's telling us it's true only when dx is greater than 2. So we're going to have to draw an open circle right here at 2, and then to the right. So now let's write the domains. The domain for the red one is going to be from negative infinity all the way to 1. And again, the 1 is not included because this is an open circle. Then we have the second one is going to be the domain from from positive 1 to positive 2. Again, both are closed circles, so it's just going to be 1, 2 with both brackets on both sides. And then the domain for the last one is going to be an open circle from 2 to infinity, because again, we start at 2 with an open circle, so that's why it's the parentheses and not the brackets. The parentheses for the infinity is always a parenthesis. You never put a bracket around it. You only put a bracket around the numbers that are included. Since infinity is not a number you can reach, that's how you keep a parenthesis. So everything else that is not part of the domain, like those two blue dots, I can erase them. And this will be your final graph with domains next to it. All right, so for this problem, I'm going to start by drawing the graph again. Okay, so we have for the first one, I'm going to put it in red, we have g of x is equal to -3. That just means that we're going to have a point at -3 at any point in that graph. But they're telling us it is when the x is less than -4. So it's only from here, and it's telling us that it's included. So from there to the left, that's all that part of the red graph is going to be. Now for the blue one, we have g of x is equal to x. Again, that's going to start right at 0. We're going to go up a few points, down a few points. And it's telling us that this is true from when x is equal from -4 to 2. But it's not included. So I'm going to do an open circle and an open circle. Just going to draw the in-between line. And then lastly, we have this one I'm going to do in green. We're going to start +6. That's up here. We're going to go down 1 into the right one, down into the right one, down into the right one. I'm just drawing the graph a few points. Now it's telling us that it is true for where x is greater than or equal to 2. So that is right here, and it's a closed circle. And it's going to look like that. Now the domain for our red one is from -infinity to -4. It is included because we have the closed circle. Then we have the domain of the blue one, which is going to be from -4 to 2. Again, not included. And then we have the domain for the green one from 2 to infinity. Again, the 2 included in a bracket. All right, that is it for today's notes.